This is lesson 1 from unit 2 of the geometry portion of math 1. Cool down called making angle bisectors. When you do a translation or a rotation or a reflection, just a quick reminder, those are called rigid transformations because the image that you end up with is the same size and shape as the original, even if it is a mirror image. Now, when we take a triangle and we slide it over, we get this exact same shape over here. And what you need to know from this lesson is this idea of corresponding parts. If this is like A, B, C, this over here would be A prime, B prime, C prime. Corresponding parts means that this side length right here ended up being this side length over here. Those are corresponding parts. This angle right here becomes this angle over here. Those are corresponding angles. So if two figures are not congruent, there is not a rigid transformation that can take one figure onto the other. If they are congruent, then there is a rigid transformation that works because congruent, same size, same shape again. The same rigid transformation can be applied to individual parts of the figure, such as segments and angles, and they move every point on the plane. So corresponding parts are congruent. Corresponding parts of two congruent figures are congruent to each other. When we're talking about triangles, there's this idea, it's CPCTC. Corresponding parts of congruent triangles are congruent. So let's take a look at this. Triangle A prime, B prime, C prime, that's this triangle over here, is a reflection of this triangle over here across the line. So we're taking this triangle right here and we're reflecting it over here. So A becomes this image over here, A prime. I don't like this. I would have done that backwards actually. I would have said C prime equals C just so that it's clear that the transformed triangle is on the left and not on the right. Anyway, the point is we need to prove that ray BC is the angle bisector of angle A, B, A prime. So this angle right here. What we're trying to prove is that this is the bisector of this angle. Now, quick reminder, angle bisector is a line or a ray that takes an angle and cuts it in half into two separate equal angles. So, knowing that this triangle got reflected over to this triangle, what you need to be able to prove or explain is how this angle and this angle are equal to each other, making this the angle bisector. How can we do that? Thinking in terms of a reflection and the idea of corresponding parts of congruent triangles are congruent. Reflection. That's it. I hope this helps. I don't know if it will. Let me know if you have any questions.